All right, we're almost done with this section and the whole unit. Just stick with me. We're almost there. So let's kind of talk about the opposite of what we're talking about. Thunderstorms, monsoons, thunderstorms that induce tornadoes, thunderstorms that began in Africa, that develop over a few stages to create hurricanes. Let's talk about kind of the opposite of that, a drought. All right, so very much still severe weather, and can have far-reaching damage, even more far so than thunderstorms or hurricanes. So a drought is simply defined an extended period of low precipitation. The issue is that not only does it produce a shortage of water for people, but for animals, for plants. It affects more people than any other natural hazard. Droughts can happen anywhere. Therefore, they can affect more people than any other natural hazard. They're causing water and power shortages and agricultural problems. Think about what's currently going on the Colorado River, and how the lake levels of Lake Mead and Lake Powell are dropping. These are two dammed up reservoirs behind dams, which generate hydroelectric power. If there's less rain, less water to fill up these reservoirs, and the lower these get, the less energy or electricity they'd be able to generate. So loss of water can also create power shortages. The defined beginning and end of a drought is kind of different that everywhere that you go, because it's based on normal conditions in a certain area, and is also population and or land use dependent. Typically, it's not a drought if there's no one there. It's not a drought if there's not a lot of farms that don't necessarily use up the water. Farms tend to use more water than people. So anyway, it's, when we're talking about normal conditions, if you think about normal conditions in Phoenix versus normal conditions in Seattle, well, Seattle gets much more rain than we do here, so their drought might be triggered a little bit differently. To us, that might still seem like a lot of water, a lot of precipitation, but to them, it's below normal. So it's different based on where you are, population, land use, etc. In general, again, it's a period of usually dry, persistent weather. It has to maintain that dry, low precipitation for a while, long enough to cause serious problems such as crop damage, water supply shortages. As far as that's kind of at the state level. At the federal level, a federal drought is designated automatically for when a county, so it's county by county, enters a D2 drought. More on that in a second, which is known as a severe drought, and those conditions exist for 8 weeks in a row. So there are different criteria. But again, each state has their own drought designation criteria. In Arizona, a drought is declared when a prolonged period of below average precipitation, severe enough to negatively impact the environment and human activities occur. There's no number there. Again, it's looking at low numbers from normal, below average, and if there are things affected. People are affected, farms are affected, animals are affected, vegetation's affected. There's no number for that. It's just kind of there's a committee that gets together and says, yep, we're in a drought. It's declared over in Arizona when a series of above average precipitation events, especially during winter, that's key, especially during winter, and specifically in the form of snow, are needed. So one wet winter is not enough to rehydrate the soil and vegetation. One storm is not enough to rehydrate the soil and vegetation. It takes a number over prolonged. It takes a long time to get into a drought. It takes a long time to get out of a drought. It doesn't just happen overnight. Oh, we got a lot of rain. We're out of the drought. Nope, not how it works. But again, snow. It's actually weird that it's tied specifically to snow. Can you think why that is? And remember, we don't get any snow here in the Phoenix area, but Flagstaff and other areas, the White Mountains, get plenty of snow. You know why that's tied to drought? Because snow and the steady runoff it provides is actually much more beneficial than rain, which is often more temporary when recharging streams and groundwater. When it rains, it soaks into the ground, that's it. When it snows, all right, it snows, and if it's in the wintertime, again, snow is specifically in the wintertime, then it accumulates, and then in the spring, it slowly starts to melt. So it slowly starts to feed those water systems, and it does so over time throughout the spring and summer. It's not just one rain, well, that rain there and gone. But these melting snow can continue to replenish streams and rivers and groundwater over a longer period of time. That's why snow is so important. It functions as a natural water reservoir, storing water again on top of the mountains in the winter when there's less demand for it, and gradually again releasing it in the form of runoff during the spring and early summer when water is in higher demand. So, where in the U.S. is the most severe drought occurring right meow? There is a lot of drought around the U.S. Can you guess maybe where the most severe drought is occurring? Maybe you heard about things on the news, wherever. Well, according to the most recent statistics, right over here, right in the West. Not so much in the East, all right? Right over here in the West. So the different colors indicate different levels of drought. White means no drought. So you can see maybe about a third of the country is in no drought. Everything else is in a drought, from D0 to D4. You can see us here in Arizona. More on that in just a second. But again, extensively through California, into Nevada, into Oregon and Washington. Looking at Washington, not on the west side where there's precipitation, but on the east side, on the rain shadow. We're not getting a lot of precipitation. See, it's all coming back, huh? All coming back. S and L stands for short-term or long-term drought. You can see here in Arizona, we have an L, we are long-term drought. And more on that in just a second. So, how does this look from now compared to a year ago? Pretty much the same. Still, the West is where the drought is occurring. Again, and that's a big part of the country. You know, that's probably 2/3 of the country where the drought is. And only really no drought in this area, all right, or around the Great Lakes. So, water, water, water. You know, in Arizona, we've been in a drought for years now. The climate's changing, it's getting warmer, it's getting drier, things aren't getting better. So water is going to be of the utmost important resource around the world. And guess what we don't have a lot of here in the Phoenix area? Say it with me now. Water. In a generation or so, this place is going to be a ghost town. It really is. There's no water to go around. So I always get the question, well, where do we go? Oh, it's a place with water. Don't buy a home here. Don't. I'm not making this up. It's not a conspiracy. Just look at the information and facts. And I don't know if I mentioned it in this class, but I've done some volunteer work on a committee for the City Council of Avondale, on the Energy, Environment, and Natural Resources Committee. And one day we were discussing how much water Avondale has left. It was like 23 years. It's 20-something. I can't remember the exact number. I think about it was like low 20s. Avondale has 23 years of water. Think about how, and that's at current rates. Think about how Avondale is expanding. More houses going up everywhere you look. More businesses going up wherever you look. All of that, all those people need water. So that number is a reflection of what's happening right now. It's only going to get worse. I'm not making anything up. It's not a conspiracy. Don't buy a home here. Move somewhere else. So I get the question, where? I don't know, someplace with water. Seems around the Great Lakes. These areas seem pretty nice. Or the southeast, if you like the southeast. It's kind of hot and humid for me, but at least they're not in a drought. But yeah, maybe around the Great Lakes, that seems like a good idea. Ohio, where I'm from, seems pretty rich in water. So Arizona, here we are, Maricopa County right here. We're kind of in a D1, D0, D1. Phoenix is right in this area over here. No, I'm sorry, Phoenix is right here. So we're in a D1 moderate drought. Plants are stressed. Hillsides are usually brown. Go figure. Ponds and creeks are nearly dry. Go figure. Sounds about right. So what this is showing you is 100% of the state is in a drought. 76% of it is in a D1 or below. 34% of it is in a D2. 9% of it a D3. And we don't have any D4 exceptional drought areas here in Arizona. But again, the whole state's in a drought. And that means even though we're in a desert, that doesn't mean we're always in a drought. It just means we're even more below the normal. We're even more below average in terms of precipitation, etc. So we're even drier than the dry we usually are. Not a good thing. So this is a interesting image that looks at droughts in Arizona from the year 2000 to present. So this shows the different colors of different intensities. So any color from yellow to the dark red indicates drought. All right, indicates drought. When you don't see any color, that means we're not in a drought. So there have been times we're not in a drought. Look, for almost all of 2001, no drought. A little bit in the middle, but for the most part, no drought. Awesome. So, in fact, from 2002 to about 2009, we were in a drought. Then we got out of it, and then we got quickly back. We were out of it for like a month or two, and then we're right back into it. And in fact, one of the longest droughts in Arizona history, well over, I think it was, well over 10 years. So there was another drought, and then we got out of it, and then we got right back into it a few months later. So now we're in another drought as well. A very intense one, too, as you can see. It looks like maybe we're coming out of it. It looks like it got bad, but then maybe we're coming back down. To be determined, but that's how these things happen. You can see how these go up and down, up and down, up and down. But, yeah. So we've been out of drought, like, for a month, maybe a couple months in 2019. Who knew? Because, that was COVID, I think. Was that 2019? Or was that 2020? I don't even know anymore. But in any case, droughts, very real reality, big chunk of the U.S. as well as around the world. Droughts are a little bit different than heat waves. Droughts are just tied to precipitation. Yes, usually the hotter it is, the less precipitation, but that's not always the case. But there are also heat waves as far as weather and severe weather events. Heat waves, prolonged periods of extreme heat that are both longer and hotter than normal. So droughts and heat waves, they can go together, but they are distinctly different things. They often accompany either severe humidity or extreme dryness. It doesn't necessarily have to mean drought, but again, they can. When we're talking about heat waves, it's important to monitor something called the heat index. Not just the temperature, but something called the heat index. A heat index is the body's perception of the air temperature. What does it feel like? Okay, it may be 110 degrees outside, but what does my body make it feel like? Here in Arizona, where the humidity is rather low, 110 degrees feels like 110 degrees. There's not a lot of humidity. Humidity is moisture in the air. The more moisture in the air, that acts kind of like a blanket. Think back to what we talked about and what keeps the earth warm. So it acts as water, moisture in the air acts as an insulator, kind of like a blanket, so it makes you feel warmer than you normally are. So if you're in an area that's humid, it might be 85 degrees, but with very high humidity, 100% humidity, it could feel like 120. Whereas here, it's 110 with no humidity, and it feels like 110. That's where that "it's a dry heat" term comes from. Heat waves are really exacerbated, by the urban heat island effect, which I'll talk about here in a moment, but it can cause urban areas like cities to be up to about 12 degrees hotter than the surrounding areas. So this is a chart that gives you the heat index, what the body feels the temperature is like. So it could be, 90 degrees and low humidity, 40% humidity, and it feels like 91. But if it's 90 degrees and 100% humidity, it feels like it's 132. So like the areas in the south, the southeast, where it's hot and humid, the heat index is much higher, which can cause things like heat stroke, muscle cramps. So it's the heat index you want to kind of worry about. And this is exacerbated, by the urban heat island effect. Think of Phoenix. A lot of buildings, a lot of roads, a lot of concrete, a lot of asphalt. All that material retains heat, and it holds on to that heat. So even at night, then those roads and buildings release the heat, creating what's called this urban heat island effect. Because of all of this heat retaining material the buildings and roads are made out of, and releasing that heat, the cities is going to be much hotter than it is if you get out into the suburbs or even out into the rural areas. I remember one night I was in a concert, came out of the venue blistering hot, and I got home and it seemed so much cooler. That's due to this urban heat island effect. Why? Because of all of those things I just mentioned. Roads, buildings, etc. You know what? Let me give you one more part of the super secret code. It is the number 43. You got me? 43. One more time. 43. All right. we'll pause here. When we come back, I think we're going to be on our very last one, how all of this impacts society. I'll see you back here in just a second.